React Native developers, in this lesson, we're going to build a nice graph user interactions. So here we have a graph which is drawn with React Native SVG and with the help of D3 based on the data point. D3 gives us a nice SVG path that we want. And we can move the cursor around, see the values for that position. And this is done entirely on the UI thread. And then when we release the gesture, we have a nice decay. This example is super exciting for 3 reasons. First, so far we've seen that the Reanimated 2 API is a much simpler API because we can use JavaScript on the UI thread. Here we're going to see that it's not only a better API, it's a much more powerful API as well. Because here we are formatting the JavaScript values on the UI thread. We are formatting the values using JavaScript. And that's something we simply couldn't do in Reanimated 1. In Reanimated 1, to implement such an example, we had to cross the bridge every time basically the cursor was moving. So we had to use a request animation frame. We had to use some throttling. We had to use set native props to not trigger a re-render while updating the values. And of course, this was not very performant on low-end devices. Here, we are not crossing the bridge. Everything is done on the UI thread. So Reanimated 2 is enabling new use cases which were not possible to do before, and this is certainly one of them. And that gets us to the second reason this example is super exciting. Because in this example, we have some code sharing between the JavaScript thread and the UI thread. So in actually a typical graph example, so here we have some formatters to format the date time and the price value. Usually you're going to share, for instance, the code to format these values between the UI thread here and the JavaScript thread. For instance, if you want to display some legend in the component, some X and Y axis. Here, we use code sharing, for instance, for the scaling. So we use scaling to, given some data points, scale the height and width of the graph and the position of each value. And then we need to scale the scale on. So this is on the JavaScript thread. And then we need the scale, invert scale to go from the position here, X, Y axis, back to the data point on the UI thread. And so we have code sharing between the UI thread and the JavaScript thread. And I find it to be quite exciting. And the last reason this example is super exciting is that we are using some SVG tooling. We are using some simple Bezier tooling. And these are much easy to, much more easier and robust to use with Reanimated 2 than Reanimated 1. And here, the mathematical tooling we're using here is very simple. And we're going to ramp it up in the next videos. We're going to use more and more complex mathematical tools on top of such a graph. And it's such a pleasure to do with Reanimated 2 because we can just use JavaScript code directly. So to implement such an example, we have data points, and D3 is helping us to get the SVG path to draw. And then we use React Native SVG to draw the path. We take the path and we need to calculate. So this path is a concatenation of Bezier curves. We need to calculate the total length of the path and the length of each curves. So when we move the cursor with the pan gesture handler, based on the X position, we can find out at which part of the curves we are and which is the length of the curves based on the position. And then that can give us the X and Y position of the cursor. So when we get the path, so this is the function provided by Redash, we parse the SVG path. If they are relative values, we normalize them so all the coordinates are absolute, and we normalize the SVG path, which is an interesting function that we don't need here, but what it does is that if we have arcs, for instance, or lines, they can be converted into cubic Bezier curves. And this is very convenient because then we can treat really any sorts of SVG path as a concatenation of Bezier curves. And it means that we can use on extremely heterogeneous SVG path, we can apply a very homogeneous tooling, which is a Bezier curve tooling. So we take our lists or concatenation of curves, and we have, so this is the 4 points that make up the curve, the start, and control point 1, control point 2. And in fact, you can see an example of such Bezier curves here, right? You have the start, so from to control point 1, control point 2. And we have a function to calculate the length. So here I used this function from actually, a code snippet I found online, but there are many libraries you can use, which I've tested as well, which can give you the Bezier length curve. And then we have a function called getPointAtLength. So given a length, we find out at which curve we are in this concatenation of curves, depending on the length. We calculate the length within the curve. So that's what is t. And once we have t, which is the length of the local curve, we can simply use the cubic Bezier function. So this is just the mathematical formula for a cubic Bezier function in order to get the x and y coordinate. And so for any position, so we're going to move the cursor around using the pan gesture handler. And this is going to give us the x and y position of the cursor here. And then we can use the x and y position to go back to the original data points using the inverted scale. And we're going to use it to display these values and use JavaScript to format the date, time, and price. So let's get started. And here I'm going to switch to the boilerplate project. And you can do the same in case you want to follow along with this example. So we have our data set here. We use D3 to have the SVG path. So we use a curve to get a nice cubic Bezier curve interpolation between data points. And here, usually you would use D3 scale, but we wrote our own scale function using, it's just to interpolate because we're going to need to use it also on the UI thread. So here we have scale invert, which is we swapped the input range and the output range to get. So here we go from a data point to an X and Y. Here we go from an X and Y to a data point. And so domain for the X and Y axis, we take the mean and max value from the data set. And the range is the mean and max value from the Canva. So here 0 width for the X axis. And the Y axis, the minimum value should be at 8. And the maximum value should be at 0, right? Because we go from the top to the bottom. And here we have the SVG, but we have a gradient definition, which we use here. And then we have one path that is using the gradient fill and the path with the thick blue line that you see here. So the first thing we're going to do is to create our length animation value. So length equals use shared value, default value 0. And so this is the animation value that is going to drive the whole user interaction. Once we have the length, we have the X and Y coordinates, and we have the data points, so price and date. And so we're going to derive these 4 values from length. So we're going to create a point using use derived value. And we're going to get the X, so coordinates from get point at length. So we give the SVG path as parameter and the length dot value. And we can return the coordinates and we can return the data points. So data is X is scale invert of coordinate.x domain is domain.x, range is range.x, and same for y. So now if we, with the pangestion handler, we're able to set the proper values for length, we are golden. So let's do that, up. And so now let's write the values for length. So the cursor component, which we use here, we're going to pass the length animation value and the point animation value. So length to drive the value with the pangestion handler, and point to translate the cursor to the proper position. So in cursor, we need to wrap this one into the pangestion handler. First and unique child of a pangestion handler is an animated view. And so we have, I think, a styles called cursor container, and then we have the animated style we need to compute, and we need to create the pangesture handler. So on gesture event. So on gesture event is use animated gesture handler. And so we get, I'm getting carried away. So we get length and point as parameter, as properties. And we have the animated style. So style is use animated style. Here, so we need to return a transform with translate X and translate Y. And these values we get from point. So we can write translate X equals point dot value dot coordinates dot X. And we need to remove half of the cursor width. So minus cursor divided by 2. Same for Y. So what happens here with cursor and cursor container is that the cursor is so small. The cursor is only 30 pixels diameter. We have a bigger area, which is cursor container, that if you touch this bigger area, you will be able to move the cursor. So that makes it much more convenient. The animated style looks good, and let's do just on active. So we have event, something simple. We have event and context. So on active, we write the value for length. So we write length.value, and we interpolate from event translation X to length. So we do interpolate event.translation X. So input range goes from 0 to width, and we go from 0 to path.length. And we can add extrapolate clamp. So here the initial value doesn't look good. Can I move this around? Yes, so that's not, this is not working at all. Is it because, oops, sorry. Oh, this is why. So here I move the value, and of course now if I resume the gesture, I reset. That's good. So we need to have an offset here. So we need to have context.offset X plus event translation X. So on start, we need to calculate offset X. So we have event context. So offset, so context.offset X. Here we do the inverse interpolation. We have length.value here instead. And we go from a length to a width. So I move around. No. Let me reload just to check, to be on the safe side. Okay, move around. Now does it reset or not? It doesn't. Perfect. Isn't that cool? Now let's add some momentum when we release the gesture. So on end. We assign a decay animation to value. So with decay, velocity we get from event. So velocity x. And we need the clamping value. We clamp from 0 to path.length. Let's have a look. Isn't that cool? All right, so now let's just display the values. And we have the label component, and we need to give it the point as property. So here we do get the point. So we're going to use retext. Retext is like text, but to display, to have text animation values. So we have text, and we have some styling, right? Style is styles dot date, and here we can format or so we have date and price. We're going to use derived value to format them on the UI thread. So style dot price. That looks good. Let me do everything in let me call it data dot value dot date. I'm going to use derived value. So we have data is use derived value, and we're going to return date and price. So for date, we're going to use some JavaScript formatting functions. I took one here. So we can create a new date based on point dot value dot x. That's a timestamp. And I have a price formatting function as well here. So we have price, and price we get from point. No, it's point.value.data.x, right? Data.x, and here same for y. So let's have a look. No, it's not displaying. I know why, because these, okay, actually, so this makes sense because here I need to pass an animation value. So I need to have price and date separately, actually. So date, price. I try to be fancy, but this cannot work. So we have date is use derived value, and we return this. And same for price. So price, return. So this looks good. So now, okay, so here it looks pretty nice. We have the values. Everything is done on the UI thread. So this should perform very well on low-end devices. There is a bug right now, which I'm reporting to. So at the time I am making this video, Reanimated 2 is the first alpha release. And there is a bug right now, and I can show it to you, which hopefully I think it's going to be fixed very, very soon. So this is a bug that can happen in many situations. So you see here, nothing is displayed for the first values of price and date. As soon as price or date value change, the value is going to be displayed properly. And I have the bug in many other examples, which are completely unrelated to this graph example. So here, when I start moving, the value has changed, so now it displays. But the date, we're still on June 1st. The date hasn't changed. So we are not displaying the date. And as soon as it's changed, so as soon we went away from June 1, the dates are displayed. And then for any value, we get the as soon as it's done, everything works as expected. So hopefully by the time you watch this video, this bug will be fixed soon. I will keep you posted on that. Overall, a great example where we have the whole user interaction running on the UI thread, which was not possible before. We have code sharing between the UI thread and the JavaScript thread, which is quite exciting. And the mathematical tooling we are using is quite simple in this video, but quite easy to do with JavaScript. And this is going to enable us to ramp up the mathematical tools we can use on top of such graph user interaction nicely, because now that we can use JavaScript, the sky is the limit. And in the next videos, we are definitely going to build more complex interactions on top of such a graph. So I hope you guys enjoyed this lesson, and I'm looking forward to talk to you in the next lesson.